Welcome to this explainer. Imagine, just for a second, a really high-stakes physical security facility. Yeah, something like Fort Knox. You've got massive concrete walls, thick steel vaults, super complex alarm systems, and highly trained guards everywhere. The entire goal is to make absolutely sure nobody gets in who isn't supposed to, and that the incredibly valuable assets inside remain completely untouched. Today, however, our most valuable assets aren't bars of gold. They are digital. We're talking about sensitive data. Protecting our digital data requires building a virtual Fort Knox around our personal information. And honestly, the mechanisms we use to do that are absolutely fascinating. So, grab a mental hard hat, because today we are exploring exactly how sensitive data is protected.
Okay, let's dive into this and take a look at our roadmap for unpacking this whole ecosystem. We'll start off by looking at the reality of data breaches, then identifying your sensitive data, the core security principles, the technologies defending your data, and finally, the laws enforcing data privacy.
Section 1. The reality of data breaches.
Now, to really understand how our data is defended, we first have to look at how it's actually attacked. And when you look at the recorded data breach statistics, the sheer dominance of malicious intent is honestly pretty staggering. Hacking makes up 68% of breaches, and phishing attacks account for another 17%. When you put those two together, you're looking at 85% of all data breaches stemming directly from targeted malicious attacks. Now, sure, things like an accidental display of information or maybe a lost laptop do happen, making up 9% and 3% respectively, but it's the deliberate hacking and phishing that truly dominate the landscape of privacy breaches today. So what exactly happens when those attacks succeed? Well, a data breach is formally defined as the unauthorized release, disclosure, or access of personally identifiable information, what we in the biz call PII, or non-public information. And here's the thing. Whether this data is sitting on a company's own on-site servers, or it's being hosted by a third-party vendor up in the cloud, a data breach means one simple, devastating thing. The security perimeter has failed. Information has essentially been stolen from a system without the organization's knowledge or authorization.
Section 2. Identifying your sensitive data.
Now that the stakes are clear, we need to ask, what exactly are organizations trying to lock down? So the crucial point is that not all data is created equal, and it absolutely shouldn't be protected the same way. Organizations use classification policies, like this CompTIA framework, to gauge security needs. These basically range from the least restrictive at the bottom to the most restrictive at the top. So you have public data, like a company press release, which obviously causes zero harm if disclosed. Then it steps up a notch to proprietary data, like a product's technical specs, which could really impact competitive advantage. Next is private for internal things like employee salaries, and then confidential for stuff like business financial data. Finally, at the very top is sensitive data. This is the most highly restricted tier, representing things like trade secrets or deeply personal identifiers. Let's see how this actually translates into specific, real-world data types. We can see four major categories here. First is PII, personally identifiable information, which is like your social security number sitting in a customer database. Next up is PHI, protected health information, and that includes your medical history and a hospital's electronic records. Then we have financial information, like your bank account details and transaction histories. And finally, government information, like classified contract documents. Think about it. A medical record has vastly different regulatory and security requirements compared to a credit card number, even though both are critical. Understanding these distinctions is pretty much the first step in building a proper defense.
Section 3. The core security principles.
Enter the CIA Triad. And no, not that CIA. This stands for confidentiality, integrity, and availability. This foundational framework is often referred to as the guiding light for data protection. It's the ultimate anatomy of protection. The goal of information security is to preserve these three pillars across the entire life cycle of the data. That means whether the data is at rest on a physical hard drive, in transit moving across a network, or in use while being actively processed by an application, the triad has to hold up.
Let's break these down a bit. First up is confidentiality. You can kind of think of confidentiality like a very strict bouncer at an exclusive VIP club. The sole job here is to ensure that information is only accessible by authorized users. If you aren't on the list, you simply don't get to see the data. A great everyday example of this is how messaging apps use encryption. By locking up the data, encryption keeps a customer's private conversations completely secure from unauthorized eavesdroppers.
Next is integrity. So if confidentiality is the bouncer, integrity acts like a tamper-evident seal on a medicine bottle. It's the principle ensuring that information is only modified in an authorized manner. For example, think about your bank account. Integrity ensures that a bank customer absolutely cannot just alter their account balance to make themselves a millionaire without actually depositing the real authorized funds. It guarantees the data remains correct, complete, and totally uncorrupted.
The final piece of the triad is availability. Because, let's face it, perfectly confidential and perfectly intact data is literally useless if no one can actually access it, right? Availability ensures information is accessible by authorized users whenever it is required. The perfect example here is a hospital. A patient's medical records must be immediately available to their doctors in an emergency. Uninterrupted access is just non-negotiable.
Section 4. Technologies defending your data.
All right, time to look under the hood at the specific cryptographic technologies used to actually enforce the CIA Triad. First, let's draw a clear contrast between two very popular yet distinct data privacy technologies: data masking and tokenization. Data masking partially redacts sensitive information by replacing it with another character. It merely hides the data structurally. You see this all the time, like when your social security number is displayed on a screen as XXX-XX-8247. Tokenization, on the other hand, is a whole different ballgame. It completely substitutes the sensitive data element with a non-sensitive placeholder, called a token. It replaces the entire value with a unique identifier, like turning that exact same social security number into A1B2C3D4. The brilliance of tokenization is that there is absolutely no mathematical relationship between the original data and the token, which makes it impossible to reverse engineer without access to the highly secure tokenization system itself.
And this brilliantly illustrates hashing. A hash function takes a variable-length string of data, meaning no matter how incredibly long or short it is, and maps it to a fixed-sized value, known as a hash. It basically creates a unique digital fingerprint of the data. Since any tiny minuscule change to the input results in a completely different hash, it is absolutely perfect for validating data integrity. It's also exactly why your passwords are secure. Hashing is a one-way process. Databases don't actually store your password. They store the hash of your password. When you log in, the system hashes what you just typed and compares the two fingerprints. If they match, boom, you're in. And hackers can't reverse engineer the stored hashes back into your real password.
And then, of course, we have encryption, which is essentially the ultimate digital safe. Encryption converts normal readable plaintext data into scrambled, completely unreadable ciphertext. Without the right key, unauthorized eyes simply see gibberish. Now, there are two main flavors here. Symmetric encryption uses the exact same key to lock and unlock the data, which is super fast for big files. But then you have asymmetric encryption, which uses a mathematically related pair of keys, a public key to lock the data and a private key to unlock it. And that is the magic that allows for secure emails and safe web browsing across the entire internet.
Section 5. Laws enforcing data privacy.
Now we transition from the technical tools to the legal guardrails that actually force organizations to implement these protections. Welcome to the alphabet soup of regulatory compliance. Jurisdiction and industry dictate exactly which of these massive frameworks apply to a business. In the US, if you handle healthcare records, you fall under HIPAA, which mandates incredibly strict patient privacy controls. If you're a US-based public company, SOX regulates your financial disclosures to protect investors. But geography matters too. The GDPR is a massive piece of legislation protecting the personal data of European Union residents, requiring things like explicit consent and a 72-hour breach notification, with fines that can hit $20 million. That is no joke. Similarly, the CCPA protects the privacy rights of California residents, forcing businesses to limit data sharing and actually giving consumers the right to demand their data be deleted.
So, we've explored the attackers, the data they want, the triad protecting it, the cryptographic tools fighting them off, and the laws keeping corporations honest. But at the end of the day, it's an ongoing daily arms race between hackers and privacy tech. Every single time a new defense is built, someone out there tries to break it. Which leaves us with a provocative final thought. As our lives become entirely digital, and with data breaches constantly evolving, is your sensitive information ever truly secure? It's a question we all need to be asking ourselves. Keep learning, keep your data safe, and we will catch you in the next explainer.